All right, welcome to the first lecture, 1.1. We're going to talk about today hypotheses, theories, laws, and the scientific method. So a very fundamental just overview of science. If you had a science course before, this is going to be pretty much identical. So let's get into it. So the general flow of science works something like this. You're very curious about something, right? In my case, where my area of research is in, it's in origin of life research. So my wanting is to know, where do we come from? Well, some might say God, some might say blah, 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 X, Y, Z. But I want to figure out why. So that's my curiosity. Now, you form that curiosity in these things called hypotheses, right? Because evidently, whatever field you go into of chemistry, or however you use chemistry, there's a body of knowledge basically over you, right? Like the sky. And it's so substantial. There's so much known about the world. And in my case, the origin of life, there's a lot known. So maybe you form a hypothesis to test whatever you're trying to look at. And that hypothesis is just going to say something like oranges are orange, right? You perform experiments and you figure out, is that true, right? And if the scientific body has never done this before, well, that gets dumped into our knowledge, our pooled knowledge of the world. And you can get two things out, a law or a theory. So let's get more definitive, right, denotative of what we're talking about here. So I'm going to write up some definitions here. Feel free to take notes if you'd like. There's not going to be any practice problems for this first one. So a hypothesis right? When you declare a hypothesis in whatever research you're doing, you're basically giving a statement that explains an observation that you might be wanting to get. So our general theme here, let's say we want to know our hypothesis, if we want to know the color of oranges. So this is the overall scientific question, so to speak. What are the color of oranges? Well, you might know this inherently, but stick with me, okay? Let's say you're on a deserted island. You were born as a young lad, and you were like a villager, right? You throw spears at animals all day. Not the most scientific or fundamental way to live. Well, societally speaking. But what color are oranges? That might be a question. Your dad's like, oh, when I was a kid, I ate oranges. And you're just sitting there like, I don't know what oranges are. Okay, well, what's the color? Well, let's say we have a hypothesis. We can actually have many hypotheses. One such hypothesis is that oranges are the color orange. Okay, that's a very simple hypothesis. And notice what we said, a hypothesis, a statement that explains an observation. So, or generally an observation that you could make. So in this case, oranges are the color orange. But there's other hypotheses. So this is called the alternative hypothesis, the one that you might be trying to prove, or the one you think is most likely to happen. But there's null hypotheses too. So a null hypothesis is oranges are the color red. Now, obviously, you know that that's not true. Stick with me. Just imagine that you don't know, okay? Those are hypotheses. Remember, write this down if you haven't. A statement that explains something that you could observe, okay? You could also kind of think of it, it's not quite a research question, but it's a way to kind of put forth a testable thing that you could test in a lab and say in your research paper when you write it up, we accept the alternative hypothesis because it's true. For example, what I want to do in my research is show selection of a peptide bond or something. So I would say, the presence of this group protects the peptide bond where this one doesn't. right? Because of blah, blah, blah. And you get very specific with hypotheses, but you're not at that level yet. So hypothesis, null hypothesis, that's basically the fundamentals of hypotheses. So what happens when you collect a bunch of theories or hypotheses together? You get two things out. You get theories and you get laws. Alrighty, so a theory is going to tell you why something is. So in the example of oranges, you might say the theory of orange color, right? That might be the name of it. And basically you're explaining why oranges are orange. Okay, well, a theory that you could basically define would be like, I don't know, there's pigments in the orange, right? There's pigments in the orange doing that. So there are pigments. Oh, geez, I'm going off the thing here. My apologies. There are pigments. Okay? Hypotheses is best seen, I think, with the example of evolution. The theory of evolution, right? Charles Darwin, that kind of thing. What does that entail? Well, we observed that species change over time. We collected them together, all those hypotheses, and we said, literally, what is happening? Species are changing. So why is that happening? Well, natural selection, right? The theory of natural selection. Those kind of things, right? Evolution by natural selection, right? Maybe you've heard that before. You're basically explaining the why. Okay, but let's also talk about these things called laws, right? What this is telling you is what is happening. Okay, and typically laws are mathematical. So let's make this scenario mathematical. So theory said why, laws are going to tell you what's happening. So a law might be the law of the color of oranges, right? Oranges are only orange. Typically we put quantitative, meaning numbers behind it. So that might be, maybe you derive a formula, the color of an orange. I'll actually give you a little teaser. Maybe you defined the pigments, the what behind it. You say A equals epsilon BC, right? Where let's say you have a little device that could scan for the pigments. Well, the absorbance of light from those pigments is equal to a constant path length of that light and concentration. In fact, we'll actually see this a little later when we get to spectroscopy, which is a really fascinating facet that will kind of give you a little hazing into instrumental chemistry, right? So let's just review what we have here, and then we'll get to the scientific method and kind of how this all interplays. Hypotheses, again, are just a statement that explains an observation. So it's kind of like incorporating your scientific question. You're saying, well, oranges are the color orange, but maybe they're red, right? Maybe they're blue, maybe they're yellow. Those are your hypotheses. When you have a theory, you're explaining why something is, right? So oranges are orange, maybe because, and let's say we have a bunch of hypotheses that we've shown to be true. Well, then our theory could be, well, there's pigments in that. And then the law might say, well, based on these observations I made through my accepted hypotheses, well, I can explain maybe mathematically what's going on. That's a theory versus a law. So, or the why versus the what. So really don't die on this hill as something that you need to know definitively. It honestly comes with time. You'll distinguish, what's a law, what's a theory. It's just something that you get over time. And that's kind of some of these things here that you'll learn in this series. But with that said, I want to get to the next topic, or the next little thing, and that's the scientific method. So how do we approach making a scientific, or how, I guess I should say, how do we go about doing science. It's such a weird thing to think about now that I'm this far in chemistry. I'm 3 years of a chemistry major, and I still sit here like, it's hard to even explain the very basics, but I digress. So, the scientific method, right, how we conduct science goes something like this. And I kind of alluded to this earlier. You have a curious thought. Okay, so you think to yourself, goodness, what color are oranges? I really need to know what the damn color of oranges are. Well, you're going to form a hypothesis or a set of hypotheses. And only one of them, relatively speaking, I haven't seen it where two could be true, but usually one hypothesis is right. So you propose your hypotheses, and what you're going to do is you're going to perform an experiment. Okay, so you perform an experiment based on that hypothesis. So let's say you want to say that oranges are orange. So to perform an experiment, look at an orange. Duh. Okay? And maybe what you do is then you go back to your hypothesis and you say, I accept that hypothesis. That is true. That is what's happening. Well, then you take that hypothesis and you bring it to the body of science. Okay? However, let's say that you initially say for your hypothesis, the alternative, you say, oranges are red. Okay, so you say oranges are red, you perform an experiment, you find the contrary. Well, you would just directly say, well, it's not red. But maybe you revise your hypothesis. Now you're like, okay, oranges are orange. Awesome. Okay, you test that. You perform the experiment by looking at it again because, I mean, I really hope you can distinguish color. But let's say you're a total fool and you think oranges are not orange, right? So you go back, you fix your things, you say, okay, it's orange. I perform an experiment. It's orange. Bring it to the body of science. So science knowledge. This is that sky I was talking about. The sky of chemistry knowledge above you that is so indefinite in its size that it is practically impossible to grasp all of it. There's a study that found that you will only scratch the surface of chemistry to the extent that you only know 0.1% of all of your specific discipline, which is ridiculous. You know so little, even as like a PhD postdoc, right? You will not fully grasp chemistry, and that's okay, because the body of science, that's just how it works, unfortunately. But you contribute to this knowledge of science, and you're going to output two things. A law, okay, you're going to output laws, maybe, the mathy kind of way, or the what, you're explaining what's happening, right? You might also explain by theory or why things are, right? So maybe a bunch of hypotheses tell you, well, it's orange because there's pigments, or here's a law that we can use, a mathematical law that expresses why oranges are the color orange, okay? And in fact, we'll even see that there are things that explain that in these lectures to come up. But in essence, that's the scientific method. That's science. It's a beautiful, beautiful thing. Really short lecture here. I hope you guys enjoyed, and I really hope that you grasped it. I would love to answer your questions in the comments. There's no practice problems with this one, just due to the simplicity of this all, or the non-mathematical formation of it. Although maybe I'll prompt you with a quick question. Let's just do one more example so we have it, okay? Or let's just do an example and talk about the sorts of things as it relates to hypotheses, theories, laws, and the scientific method. So, I didn't really think of what to do here. It's going to rain today. Okay, let's just talk about the scientific method as it relates to if it's going to rain today. So take a look outside. I mean, I can look out there. It's a little cloudy. It's a little dark outside, right? These are the curious thoughts I'm having. Well, let's form hypotheses from that. So how we form hypotheses, we could say, well, maybe let's decide one factor. It's going to rain because our alternative hypothesis, or the one that we think will be true, it is going to rain because the clouds are dark. Sad face, right? No one likes rain. If you like rain, well, if you like rain in the sense that it smells good and you think it's like really nice out, that's great. But if you just like rain because it's rain, like, get a hold of yourself, man. But this is our alternative hypothesis. Here's some notation if you like the mathy kind of things. H sub A is alternative hypothesis. So if you think it's going to rain, you're going to define your alternative hypothesis to be it's going to rain because the clouds outside are dark. Well, your alternative hypothesis is it's not going to rain just because the clouds are dark. Okay, so maybe you're either the pessimist or you're the optimist. Whatever you are, these are the hypotheses, and we call this the null hypothesis, remember? So that's H sub naught, or H sub O, right? And that's it. That's the hypotheses. Now, let's think about this in the grand scheme of things and how it relates to the scientific method. Well, let's say you find a correlation, right? Maybe you go with this hypothesis, and you find that this is true. Well, let's make some more hypotheses. Why are clouds dark, and why does that cause rain? These are the fundamental questions we asked ourselves a long, long time ago. Why do dark clouds correlate to rain? Okay, why is that? Well, you might say because there's water in the clouds. So maybe you make another hypothesis that says something along the lines of it rains when there is lots of H2O in the sky. Okay, that's a very simple way to put it, but you're going to keep making hypotheses until you get such a fundamental grasp of things that you propose a hypothesis. And that hypothesis would be weather, right? Or sorry, you propose a theory that says, well, the reason that it rains is because, well, water evaporates out of the ocean and other sources of water into the sky. It forms a gas. It condenses until it can't withstand itself anymore, and it rains on us. That is how that's the scientific method. I really hope you got that. I'm going to shut up now. Let's get into our next topic.